Good day, girls. Today we'll be doing Mathematics Part 2, Geometry, Chapter 1, Similarity. We'll be doing this chapter in 4 parts. We'll be doing the first part today. Under this, we'll be doing ratio of areas of two triangle and the first exercise 1.1. Now we already know the formula for area of triangle. Area of a triangle A is equal to half into base into height. You have already studied this formula. Now let us calculate or find the ratio of areas of any two triangle. Let us consider the first triangle. Let it be represented as A1 is equal to half into B1 into H1. Let us consider the second triangle. Let the area of the second triangle be A2 is equal to half into B2 into H2. So we have areas of two triangle. Area of the first triangle is equal to half into B1 into H1. Area of the second triangle be half into B2 into H2. Okay. Now let us now calculate the area of the ratio of area of these two triangle. So since we are talking about the ratio, we will be writing it as A1 upon A2 is equal to half into B1 into H1. B1 and H1 represents the base and height of the first triangle. And the area of the second triangle is half into B2 into H2. Now this half and this half will cancel. So we have the ratios of two triangle. A1 upon A2 is equal to B1 into H1 upon B2 into H2. You need to learn these ratio values by heart, which will be helpful for us to solve the sum. Let us go into the second concept of the ratio of areas of two triangle. Let us take the area of the first triangle. A1 upon A2 is equal to B1 into H1 upon B2 into H2. We have learnt how to calculate this. Now suppose if I say H1 is equal to H2. So H1 and H2 will cancel. What we have here is A1 upon A2 is equal to B1 upon B2. So we can say the ratio of area of two triangle with equal height is equal to the ratio of their corresponding base. You need to learn this also by heart. We'll be solving sums in the first exercise. Now let's see what happens if they have a common base. So we take A1 upon A2 is equal to B1 into H1 upon B2 into H2. Now we will see that B1 is equal to B2. This B1 and B2 will cancel. We have the ratio of area of these two triangle A1 upon A2 will be equal to H1 upon H2. Okay. Now let's see what happens if they have a equal base and equal height. So we take A1 upon A2 is equal to B1 into H1 upon B2 into H2. Now if I say B1 is equal to B2 and H1 is equal to H2, all these things will cancel off, and what we have is A1 upon A2 is equal to 1. I can also say that A1 is equal to A2. So let us revise once again what we have learnt just now. We can say A1 upon A2 is equal to B1 into H1 upon B2 into H2. Then A1 upon A2 is equal to B1 upon B2 if they have a common height. A1 upon A2 is equal to H1 upon H2 if they have a common base, and A1 will be equal to A2 if they have a common base and common height. Now keeping these concepts in mind, let us go to the first exercise 1.1 of your textbook. The first sum, let's read the question. Base of a triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these two triangles. So we have the base of the first triangle as 9 and the height as 5. So here we have, and the base of the second triangle is 10 and the height is 6. Okay, so let the area, base and height of the first triangle be A1, B1, H1 respectively. The area and base and height of the second triangle be A2, B2 and H2 respectively. So we have here base and height of the triangle as 9 and 5, which we have written. B1 is 9 and HY is 5, B2 is 10 and H2 is 6 as given in the question. Now let's find the areas. Area of the two triangle A1 upon A2 is equal to B1 into H1, B2 into H2. Let us substitute the formulas, multiply and get the answers. Since we have been asked to calculate the ratio of area of these two triangles, we need to write the answer as 3:4. Let us go to the next question. Observe the figure carefully. It is given BC is perpendicular to AB and here AD is perpendicular to AB over here. The value of BC is given to be 4 and the value of AD is given to be 8. Now if you look at this figure very carefully, you have two triangles ABC and you have BAD. Both this triangle have a common base AD. So let us now calculate the ratio of area of triangle ABC and ADB. So I've written the two triangle and the ratio of these two triangles is BC upon AD. BC upon AD. These are two triangles with a common base. So the ratio of the two triangles is equal to their respective corresponding height. We substitute the values and we get the answer as 1 upon 2. We go to the next question, third one. In the adjoining figure, seg PC here is perpendicular to ray RQ and QT is perpendicular to ray PR over here. They are given the value of PS to be 6, PR to be 12 and RQ again to be 6. Find the value of QT. Now we know that area of the triangle is half into base into height. We take the first triangle, triangle PQR. So we have here triangle PQR, this triangle. In this triangle, you can rightly see that the base is RQ, which is given to be 6, and the height of this triangle PS lies outside the triangle PS. PS is given to be 6. So we substitute PQR is equal to half into RQ into PS, that is half into 6 into 6, and the answer is area of the triangle PQR is 18 square units. Now we take the next triangle again. The next triangle we are going to take is the same again, PRQ. First also, in the beginning also we took the same triangle. Now also we are going to take the same triangle. But in the first time when we took PQR, we took QR as the base and PS is the height. Now we are taking the same triangle, but this time we are taking PR as the base and we are taking TQ as the height. So we have area of triangle PQR is equal to half into PR into QT. Now this triangle area we have already calculated as 18 square unit. We are going to substitute the formula 18 is equal to half into PR 12 into QT. You can cancel 2 and this 12. 2 ones are 2 6 are 12. Then you divide it and you get the answer as 3 units. So we have QT as 3 units. Look at the fourth sum. In the adjoining figure, you have AP perpendicular to BC and you have AD parallel to BC. So the condition is given that these two lines are parallel. Find the ratio of triangle ABC, that is ABC, and ratio BCD. Now if you carefully observe these two triangles, that is ABC and BCD, they lie between the two parallel lines. Therefore, they have a common height. Also, these two triangles have a common base. So, what can you say about triangle ABC and BCD? These two triangles have a common base and a common height. So, we have already learned in the beginning and the two triangles have common base and height. Their heights are common, they have a common base, therefore the areas are equal. So area of triangle ABC is equal to area of triangle BCD. The reason you have to write is triangles having equal base and equal height. So the ratio of areas of these two triangles is equal to 1. Now the fifth question, you have to learn, identify the proper triangles as what they have asked. There are 4 sums. The sum is given to you. I expect you to go through these sums and try to solve on your own and then verify your answers. We have finished with the first exercise 1.1. In the next part, we'll be doing the theorems and then we'll be solving the next exercise 1.2. Till then, take care. Bye-bye. Thank you.